This block of standards is based on the exponential expressions standard, 8.EE.1. And part of that standard is where we may be selecting all expressions that are equivalent to the original expression, or all expressions that may not be equivalent, or maybe perhaps some other ideas. So when you're doing a problem like this one, we should take a look at the original expression, this one right here. And of course we should be doing our work down here, but I'm going to be doing it off to the side here. So the original expression is in parentheses 4 to the 4th power times 4 to the negative 1 power, all of that to the negative 1 power. So following the order of operations, we should, of course, simplify within the parentheses first. Well, within the parentheses, we have 4 to the 4th times 4 to the negative 1 power. We are multiplying expressions with the same base there, and the rule for that is to add exponents. So the first exponent plus the second exponent, 4 plus negative 1 is 3. Now we're going to deal with the power to a power. And when we have a power to a power like this expression that we have left, we multiply exponents. Well, 3 times negative 1 is negative 3. And then, of course, typically we don't leave expressions with a negative exponent. So when we talked about the negative exponent rules, we learned that we could write it like that. And 4 to the negative 4 is equivalent to 1 over 4 to the 3rd. And then I see a couple of the answers here that actually have the power of 4 actually simplified. So 4 to the 3rd power is 64, because remember, from 6th grade, and we've actually reviewed this, 4 to the 3rd is 4 times 4 times 4, and that is 16 times 4, which is 64. So that's the reason why 1 over 4 to the 3rd is 1 over 64. So I'm circling all of these because when I look over there at the answers, the possible answers to choose from, I can see that some of those are there. So I can see this one right here is equivalent. I can see that 4 to the negative 3 is equivalent. I can see that 1 over 64 is equivalent. Clearly 64 is not, and 4 to the 3rd is not. This next to last one, though, we're going to need to do a little bit of simplifying in that one. Remember, we add exponents when we have expressions with the same base, and we are multiplying those expressions. The first exponent plus the second exponent, negative 4 plus 1 is negative 3. And I don't even really need to go any further because I can see that that one is right there. So it looks like in this particular problem, we have 4 of those expressions that are equivalent to the original one. And in these type of problems, sometimes it's only 1 of them, sometimes it's 2 of them, sometimes it's 3 of them, sometimes it's 4 of them, and sometimes it may even be all of them. So you really do need to check all of the possible answers there. So once again, to do these types of problems, you would want to simplify the original expression. And in my problem, that's all this work I did right there. And then look at your possible answers and see which ones are equivalent to that. All right, next idea. Would be a problem like this. Now, even though the original problem is different, the idea that we are using is exactly the same thing. So what we want to do is we want to take the original expression, and clearly you should be doing your work down here. So the rule for dividing expressions with the same base is to subtract exponents, and it is always the top exponent minus the bottom exponent. And negative 7 minus negative 2 becomes negative 7 plus 2. which is negative 5. So that simplifies to 6 to the negative 5 power. So I can definitely see this one is going to be equivalent. But we've got to go with a little bit more simplifying here. Remember, if we end up with an answer that has a negative exponent, we typically in math don't leave expressions with the negative exponent. So 6 to the negative 5 is equivalent to 1 over 6 to the 5th. And I can see that that one is this one right here. And I can see by the answers, none of them have 6 to some power figured out. So now we just need to take a look at other answers. Clearly, 1 over 6 to the negative 5 is not equivalent to that because it doesn't look like, that one or that one. 6 to the 9th clearly is not. 1 over 6 to the negative 9 is not. 1 over 6 to the 9th is not. 6 to the 5th is not. And 6 to the negative 9 is not. So it looks like in this particular problem, only those two expressions are equivalent to the original. So once again, we take the original expression, simplify, showing all of your work down here, and then choose all of the expressions that are equivalent to that. All right, sometimes we have expressions where we may be asked for the expressions that are not equivalent to the original. Well, in my opinion, it would be easiest to write all of the expressions that are equivalent and choose the ones that don't look like that. So here's what we know. We know that 4 to the negative 7 is equivalent to 1 over 4 to the 7th. I look at all the answers over there, and I can see that none of them have 4 to some power figured out. So now we just need to come over to all of our answers and do a bit of simplifying. Well, the first answer, we're multiplying expressions with the same base, so we add exponents. The first exponent plus the second exponent, negative 1 plus negative 6 is negative 7, so I can see this one is equivalent. When we have a power to a power like in the second one, negative 7 times 0 is 0. 4 to the 0 power is 1, so that one is not equivalent. In the third one, we subtract exponents when we are dividing expressions with the same base. So top exponent minus the bottom exponent, and negative 2 minus 5 is negative 7, so it looks like this one is equivalent. When we are, once again, dividing expressions with the same base, we subtract exponents, but clearly the top exponent minus the bottom exponent is not negative 7, so that one is not equivalent. We can see that 1 over 4 to the 7th is equivalent because it looks like that. And then in the bottom one, when you have a power to a power, you multiply exponents. Well, 2 times 5 is 10, so that one is not. So in this particular problem, and be on the lookout for this, we're trying to choose all of the expressions that are not equivalent. So the ones that I just circled are not the ones that are actually the correct answers. It's really this one, and this one. Those are the ones that are not equivalent. So once again, this one, and this one, because we are choosing the expressions that are not equivalent. 4 to the 0 is not equivalent to one of these two. 4 to the negative 30 is not equivalent to one of those. And 1 over 4 to the 10th is not equivalent to one of those. Okay, so the last idea that we're going to talk about in this block of problems is a problem like this. This one says to select all expressions that have a value between 0 and 1. So while we're technically, in some respects, doing something very similar, it is slightly different. So down here in the work area is, of course, where we should be showing our work. Down here. I will be doing it off to the side. So in the top answer there, we subtract exponents when we have expressions that we are dividing and they have the same base. Top exponent minus bottom exponent, 4 minus 8 is -4. So we have -7 to the -4 power, which is 1 over -7 to the 4th power. Now, -7 to the 4th power, it doesn't really matter what that is, but we should realize that it's going to be some positive number. And so we have 1 over some positive, large positive number. Now, clearly that's a fractional value that is in between 0 and 1. So this is one answer that we would select. The second one, we add exponents when we are multiplying expressions with the same base. And the first exponent plus the second exponent is -3. And remember how we deal with fractional values to a negative exponent. That becomes 4 over 1 to the +3 power. So technically that's 4 to the 3rd. Now 4 to the 3rd is clearly not going to be between 0 and 1. Next one, 2 to the 4th times 2 to the -7. We add exponents when we are multiplying expressions with the same base. And so that's 2 to the -3, which is 1 over 2 to the 3rd, which is 1 over 8. That clearly is a value between 0 and 1. In this one right here, and I know we got kind of a mess here. So we subtract exponents when we are dividing expressions with the same base. Top exponent minus the bottom exponent. 9 minus -5 is 14. Clearly, that is some value that's not between 0 and 1. And then the last one here, 4 over 2 simplifies to 2. So we have 2 squared. Clearly, that's not a value between 0 and 1. So in this particular problem, only 2 of the expressions are between 0 and 1. So in all of these types of problems, we are going to need to do a lot of simplifying to figure out how to answer the question appropriately. In this problem, we were selecting all expressions that had a value between 0 and 1.